Okay, so what we are going to do now is take a look at how to understand the axis angle rotation mode and the quaternion rotation mode. But first, I want you to make sure that this cube is set to XYZ Euler. Now, we're going to get very technical in defining this idea behind rotation mode. So here, what Blender is really asking you is which type of rotational system do you want to use to capture the rotations of your object between keyframe to keyframe so Blender can interpolate between them. So when you have this object set to Euler, we are simply telling Blender to use a 3-ring rotational system. So as you have seen that when we rotate this object, when it is set to Euler, the values that you're going to see over here are for the 3-ring system. They are not for this object. Only the x-axis is going to be directly related to the actual local axis of this object because the x-axis is the first axis. So what exactly does this mean? This means that the object itself is simply attaching itself to the first ring. So what I want you to do is, having this cube selected, go to the Object tab and expose its local axis. So here you can see that when we rotate this object on the X ring, the object is always going to rotate along its local x-axis, right? Because the object is attached to the X ring. Because the order of rotations when we're dealing with Euler is simply based on a parent-child relationship between these rings, we know that the Z ring is always aligned to the coordinate z-axis. In this case, it's going to be the world space z-axis. And the y is simply the child of the Z ring, and the x is the child of the Y ring. Okay? So whenever we change the x value over here, because the object is directly attached to the X ring, this value will always reflect the true rotation of this object on its local x-axis. Now when we rotate this object on the Z ring, it is simply rotating around the world z-axis. Okay, and because the Y ring is the child of the Z ring, when you rotate on Y, you can see that the object is simply rotating on the Y ring. It is not going to rotate on its local y-axis. Same thing is true for Z. When you rotate on the Z ring, the object is not going to rotate around its local z-axis being displayed on it. It will only do this for the X because that is the first axis, correct? Now, if we want to rotate this object based on the axis that is being displayed on its origin point, really its local axis, we have to use the 3D manipulator. We can switch this to local, or we can keep this on global, right? Now we can press the R key and press the X key 2 times. Here we're officially rotating this object around its local x-axis. Now it just so happens that this object is attached to the X ring. So of course that number is going to change. But if we press the R key and press the Z key 2 times to rotate this object around its local z-axis, then all the numbers are going to change, right? So here you can see that these numbers are simply always talking about the internal ring system. They are not talking about how this object is rotating on its local axis. It's only going to do this for the x-axis because that's the first axis, right? So if you click over here, whatever the first axis is, that's what the object is going to attach itself to, that ring. Okay, this is a really important distinction over here. When you come in over here, this is what Blender's asking you: which type of rotational system do you want to use to capture the rotation of this object? Okay, now here, of course, if you press the R key and press the Y key to rotate this around on its local Y, you can see that all the numbers over here are going to change, because the Y ring again is just simply the child of the Z ring. Now you've seen how this entire concept works when we're dealing with Euler rotations, because it's simply a ring-based system. I want you to do Alt-R to reset the rotation. Now when you click over here and say that you want to use axis angle, here you're telling Blender that now you want to use a pole rotational system rather than a 3-ring rotational system. That is what Euler rotations are for. Okay, so just like when we had exposed the 3 rings to see how they work internally, here we're simply exposing this pole rotational system. This is what this pole is for. Now I want you to click on this cube. Now what I want you to notice is these values. What exactly do they represent? They represent everything about what this internal pole is doing when you are rotating this object. So the value of W simply represents how much this pole is going to rotate around its long axis. Okay, and these values over here are simply location values, telling this pole how to or where to point depending on how you rotated this object. Now by default, when you choose axis angle and when you do Alt-R to reset the rotation of this cube, the value of Y will always be at 1. What this simply means is that it's telling you that this pole will be aligned to the local y-axis of this object. Okay, meaning that really the starting rotation of this object, which is always aligned to its coordinate system that it is using. So to visually see this, just click on this pole, press the 3 key to go to the right view, and press the R key, press the Control key down, and just lay it down like this. So now when you click on this cube, this is what these numbers are stating, that the pole right now is aligned to the Y. Okay, its original starting rotation, which is set to 0. And of course, it's just going to align to the world y-axis, because that's how all objects come in inside the 3D view. They are always aligned to the world coordinate system. Now, we're going to understand how this concept works by hand first. Then we can use drivers to automate this process. So what I want you to do is go ahead and click on this pole and do Alt-R to reset the rotation. So right now the pole is aligned to the local z-axis of this object. So here we're going to make this a true fact. All we have to do is type in 1 over here and type in 0 over here. That's all this means. Now, because these are location values inside a unit sphere, these are simply stating that if you could imagine that if you had a ball, you can simply position this ball based on the values that are being displayed over here, and then tell this pole to point to this ball. Okay, so what I want you to do is go ahead and click on this pole, go to the Object tab, and for now just remove the parent. Go ahead and click on this ball and actually press the S key to scale this out a bit so you can select it a little easier, and go ahead and remove the parent. Now what I want you to do is click on this cube and make sure that it is set on axis angle. Make sure that the view is kind of like this, and now press the R key 2 times to rotate. Now press the 1 key. Now here I'm going to press the R key again 2 times and just rotate in a way so it looks a little nicer. Okay, and that's it. So now what we're going to do is understand what exactly is happening to the pole. It's very easy. All we have to do is first take the X location value, hover our mouse to Control C, and go to this ball over here, go to its X location, do Control V. You're going to see that the ball is moving inside a unit sphere. Go ahead and click on the cube, get the Y, Control C, go to the ball, and here do Control V, go to the cube, and over here we're going to get the Z, Control C, go to this ball, and over here we're going to do Control V. Notice that where the ball is going. All you have to do now is click on this pole, go to the constraints, over here do damp track, and select the ball, and over here we're going to do Z. Notice that this is where the pole ended up pointing. So what exactly is this doing? It's just actually very simple to understand. So here is how we have rotated this object, right, from its original starting rotation. So now if we want to put this object back, meaning to where it came from, all we have to do is take a look at how to do this with the pole. So what I want you to do is right now just click on this cube, press the shift key down and click on this pole and create a parent-child relationship. The reason we're doing this is now when we rotate the pole, the child, which is the cube, will simply going to follow it. Now check this out. Now when you press the R key and press the Z key 2 times and rotate this cube around this pole, notice that magically the cube comes back to its original starting rotation. This is the idea behind axis angle. So now if we click on this cube and take a look at these numbers, 43.397, click on it, press the R key, press the Z key 2 times, and here in my case, because that's my rotation, I'm going to type in 43.397. I'm going to type in minus and enter. Notice that the object went back to its original starting rotation. That's the idea behind this. Okay, this is how this works. So here I'm going to go ahead and do Alt R to reset the rotation and just remove the parent-child relationship. Go ahead and click on this pole, do Alt R to reset the rotation, and Alt G to location. Click on this ball, do Alt R and G to reset everything. Okay, so now you can see how this works by hand. What we're going to do now is actually automate this process. So what we're going to do is actually go ahead and click on this ball, press the shift key down, click on this pole, and now click on this cube and do Control P to create that parent-child relationship. The reason we're doing this is because we want to be able to click on the cube and move this. Now what we're going to do is basically automate this process. Simply go ahead and click on this cube and make sure that it is set to axis angle. Now click on this ball, and over here we're going to right click, add drivers, and we're going to do manually create later. So we're going to inject the location values coming from this cube. Now go ahead and open this up first. Go to the graph editor, and here you're going to switch to drivers. Go ahead and click this ball, click on the X and open this up, click on drivers and just push it over here. Now you will notice that because we want the location values from this cube, we're going to click over here and select this cube. You will notice that we don't have access to axis angle. This is where we have to choose a single property. Now when you click on this cube, because we're using this, we have to right click over here on the X and do copy data path. Now we have to go back to this ball over here, just do Control V, click over here and type in .x, enter. Now take this variable over here and just type in VAR and enter. Okay, Now what we're going to do is simply having this ball selected, right click, and over here do copy driver, then on the Y right click, do paste driver, right click and paste driver, and just click over here to refresh. Now click on the Y location, click over here and do backspace and type in Y, enter. Now click over here on the Z, click over here, backspace and Z, and enter. Okay, now go ahead and shut this off. Now you will notice that when we click on this cube, do Alt R to reset the rotation. As I've shown you that by default it's going to be set to 1. Notice what's happening to this pole. Because the ball is based on a unit sphere, based on its location, it's on the value of Y on 1. This is why this pole is pointing in this direction, because we still have the constraints on it. Now notice this, when you click on this cube, now press the R key to rotate it. Notice that how the internal pole rotational system is working. Okay, so what I want you to do is press the R key 2 times and just rotate the cube again, just like this. Press the 1 key and just rotate it kind of like this over here. Notice how the pole is working. Okay, so what we're going to do now is to make sense out of this is first we're going to click on this pole, do Shift D to duplicate it, right click to cancel, do Control A and do visual transform. Notice the name of this duplicated object. Now go ahead and turn off the jump track. In the same way, click on this cube, do Shift D to duplicate it, and then right click to cancel. Notice the name of this cube. Now click again on the cube until you get to the original cube and do Alt R to reset the rotation. Now if you do the middle mouse button, you can see that this cube has gone back to its original starting rotation, and this is where the pole is pointing. Now if we take a look at where we were, this is why we captured it, because what we're going to do is now click on this rotated cube, press the Shift key down, click on this pole, and do Control P to create that parent-child relationship, right? This gives us the ability to click on this pole, press the R key, press the Z key 2 times, and see that how this object magically comes back. Okay, so here you can see that when we click on this cube, we can see that it's 43.603. 43.603. I'm going to do minus, enter. See, it goes back to its original starting rotation. This is how axis angle works. We're going to do Control Z to make it go back to the way it was. And here, just click on this cube and click on this pole, do X and delete. So now you have a automated axis angle rotational system. So you can see how this concept is going to work. So what I want you to do now is go under File, do Save As, and save this as a rotation concepts 16.blend. Okay, so I'll see you in the next lesson where we will take a look at how does the quaternion rotational system work.